Imagine being able to mold the digital world at your fingertips. That's the power Java's object-oriented programming bestows upon you. Welcome to the fascinating realm of Java, a programming language that's as dynamic as it is pervasive. Java is a staple in industries far and wide, from cutting-edge tech firms to financial institutions, healthcare, and even entertainment. It's the unseen force that powers the apps we use daily, the websites we visit, and the games we play. But what makes Java so powerful? Well, it's all thanks to a paradigm known as object-oriented programming, or OOP for short. OOP is a programming model organized around objects rather than actions and data rather than logic. In essence, it's like building with digital Lego blocks where each block or object carries specific characteristics and functions. In Java, these objects are instances of classes which are like blueprints that define the properties and behaviors of an object. For example, if you were to create a video game, you might have a player class, which could have properties like health, strength, and speed, and behaviors like run, jump, and attack. You could then create multiple player objects, each with its unique set of properties and behaviors. The true beauty of Java's OOP lies in its ability to create flexible, reusable, and modular code. This means you can write code once and use it multiple times in different contexts without having to rewrite it. It's like having a toolbox full of versatile tools that you can use to build a myriad of digital creations. Java's OOP offers a whole new way of thinking about and solving problems. Instead of focusing on how to solve a problem, you focus on what components you need to solve it. This shift in perspective allows you to tackle complex problems with greater ease and efficiency. In Java, every problem is a puzzle waiting to be solved, and every solution is an object waiting to be created. So are you ready to harness the power of Java's object-oriented programming and start crafting your digital world? In the world of Java, we build with blocks not made of wood or plastic, but of code. They're called classes and objects. Think of a class in Java as a blueprint for creating objects, a bit like an architect's plan for a house. It lays out the design, specifying the properties an object should have. These properties are known as fields or variables. Say, for a dog class, the properties could be breed, color, or age. The behavior of the object, such as barking or wagging its tail, is defined by methods within the class. Now, an object is simply an instance of a class. Using our dog class, we could create an object named Fido that is a brown 2-year-old Labrador who loves to bark at squirrels. But why stop at one? Just like a blueprint can be used to build multiple houses, a class can be used to create multiple objects. Fido could have many doggy friends, each with their own name, breed, colour, and age. Now let's talk about inheritance. Not the kind where you get your great-aunt's antique clock, but the kind where one class takes on the properties and methods of another. It's like a family tree for classes. For example, a puppy class might inherit characteristics from the dog class, but with additional properties like cuteness level. Polymorphism is another key concept. It's a big word, but don't let it scare you. It simply means that an object can take many forms. A dog object could also be seen as an animal object, a pet object, or even a barking object, depending on how we look at it. Finally, we have encapsulation. This is the idea of bundling the data, our variables, and the methods that manipulate this data into a single unit, our class. It's like packing a suitcase for a trip. Everything you need is in one place and it's protected from being accidentally changed or accessed. To sum up, classes and objects are the building blocks of Java's object-oriented design. They allow us to create complex applications by breaking them down into manageable parts. Inheritance lets us build on existing classes. Polymorphism allows our objects to be versatile, and encapsulation keeps our data safe and organized. Just as a building stands strong with its bricks and mortar, your Java application stands strong with its classes and objects, utilizing inheritance, polymorphism, and encapsulation. Theory is great, but let's see these concepts in action with a programming example. Picture this. We're playing a virtual card game. In this game, each card is an object. It has properties like its suit and rank, and it can perform actions like being dealt or flipped over. Now think about a hand of cards. A hand is not just one card. It's a collection of cards. In Java, we'd represent this as a class called hand. This hand class would contain an array of card objects, and it would have methods to perform actions like dealing a card adding a card or removing a card. Similarly, a deck of cards is also a class called deck. This deck class would contain an array of 52 card objects. It would have methods to shuffle the deck, deal a card, or check if the deck is empty. So, in our card game, we have objects, the cards, and classes, the hands and the deck. The cards, hands, and deck interact with each other to create a functioning card game. For example, when the game starts, the deck class might use its shuffle method to randomize the order of the card objects. Then, it might deal a card object to the hand class, which adds the card to its array of card objects. In this way, our card game is a wonderful demonstration of objects and classes in action. Each card is an object with its own properties and actions. The hand and the deck are classes, each containing multiple cards and performing actions on those cards. And all these objects and classes work together to create a functioning, interactive card game. Objects and classes are the heart of Java's object-oriented design. They allow us to create complex, interactive programs out of simple, reusable pieces. They give us the power to create virtual worlds, games, and applications with just a few lines of code. Our card, hand, and deck example beautifully illustrates how objects and classes weave together to form a coherent, functional program. Java's object-oriented power is fascinating, isn't it? It's like having a toolbox full of versatile tools that you can use to create just about anything you can imagine. And the best part? Each tool, each class or object has a specific role and purpose, making your coding journey a whole lot smoother. We've navigated through the intricate world of Java's object-oriented design, shining a light on its building blocks. We've understood that classes are like blueprints, defining the properties and methods that an object will have. These objects created from classes are the real-world entities that interact with one another in our programs. A class is a concept, an idea, while an object is the tangible embodiment of that idea. We've also delved into Chapter 5, where we dissected objects and classes, breaking them down to their core elements for easy understanding. We've seen how objects encapsulate data and functions into a single entity, providing a way to structure programs that mirrors real-world concepts. Then we dived deep into Section 5.4, where we brought all these concepts together. We played with the programming example of card, hand, and deck, showing how these ideas come to life in a real, functional Java program. We've seen how classes and objects interact, how they work together to create a dynamic and interactive program. But this is just the beginning. Understanding these concepts is the first step towards mastering Java's object-oriented programming. There's a whole universe of concepts and techniques waiting to be explored. Abstraction, inheritance, polymorphism, encapsulation. These are not just fancy terms, but powerful tools in the hands of a skilled Java programmer. Remember, every line of code you write in Java is a step towards mastering the art of object-oriented programming. So keep practicing, keep coding, and unlock the power of Java's object-oriented design. All right, folks. It's time to get our hands dirty and delve into some real Java code. We're going to create a dog class and a Fido object. Are you ready? Let's dive in. First, we define our dog class. We give it properties like name, breed, and age. These properties are variables that hold the state of the dog. Then we provide our dog class with methods like bark and wagtail. These methods are functions that define what a dog can do. Now let's bring our dog class to life by creating an object. We'll call this object Fido. Fido is an instance of the dog class, meaning it has all the properties and methods that we defined in the dog class. However, Fido has its own unique name, breed, and age. Once we've created our Fido object, we can start calling methods on it. Want Fido to bark? Just call the bark method. Want Fido to wag his tail? Call the wagtail method. It's as simple as that. And there you have it. A simple yet powerful example of how classes and objects work in Java. Remember, Fido is just one of the countless objects you can create with your dog class. The possibilities are endless. So keep coding, keep experimenting, and continue to unlock the power of Java's object-oriented design.